All right, here starts Unit 7, Trigonometry. And we're going to start with what is an angle, okay? So here's the definition of an angle. We have an initial ray and we have a terminal ray. And the angle is the degrees between the initial and the terminal ray. Notice that going counterclockwise on the Cartesian coordinate system means that it is positive. Let's take a look at the other way. Again, we're going from the initial to the terminal ray, but this time we've gone clockwise. So remember, this is going to be a negative angle. Coterminal angles. These are angles with a common terminal ray. Notice there's our terminal ray in quadrant 2. Okay, so if you've gone clockwise, then it's considered negative 5 pi over 4. And this is Radians measure, which we'll get into in a little while. If we move counterclockwise to the same terminal ray, then the measure is 3 pi over 4. Okay, and so these are coterminal angles. Let's take a look at what happens when we go around the circle more than once, but coming to rest at our terminal angle. Okay, that angle is a negative 13 pi over 4, but again, it is considered a coterminal angle to the 3 pi over 4 as well as the negative 5 pi over 4. So to find the coterminal angle, since 2 pi equals 0, it can be added or subtracted from any angle to find a coterminal angle. So if you're given negative 3 pi over 4, then if we go ahead and add the 2 pi, now notice that you're going to have to convert this to a fraction. So 2 times 4 is going to be 8. And so it's going to be 8 pi then over 4. And so negative 3 pi plus 8 pi will give you the 5 pi over 4. And again, this is working with fractions and everything has to have a common denominator. Let's take a look over here. Again, we must change our minus 2 pi to 8 pi over 4 because that is what our fraction is a 4, the denominator. If we sit here and remember that there is the minus in front of the 8 pi, so negative 8 pi plus a negative 3 pi gives you the negative 11 pi, and again, the denominators are just 4. Let's take a look at radian measure, okay? Let's define radian measure, okay? 1 radian is actually an angle of 57.3. If you actually take your radius and move it along the circumference, you will go an angle of 57.3, okay? So the circumference of the circle is equal to 2 pi r, which we would call 2 pi radii, or you can say 2 pi radians. 360 is equal to 2 pi radians. 180 is equal to pi radians. All right, let's take a look at the unit circle radian in radian measure, okay? We're going to put this triangle here. This is a right triangle. This theta is going to wind up being 30 degrees, okay? When we put this onto the circle, we find that this is going to be pi over 6. So you need to remember that 30 degrees is going to be equal to pi over 6. Okay? And so on the outside of our unit circle, we would put pi over 6. If we move another 30 degrees, and now we have 2 of them, so we have 2 times pi over 6, notice that we can reduce that to pi over 3. If we go another 30 degrees, okay, Then we get 3 times pi over 6, which we reduce to pi over 2. And that's our first quadrant, which means pi over 2 is equal to 90 degrees, just like pi over 3 is equal to 60 degrees. Okay, we're going to continue into the second quadrant. Now we've gone another 30 degrees, so this is 4 times pi over 6, and that will give us 2 pi over 3. We go another 30 degrees, and that's 5 times pi over 6 for 5 pi over 6. And then on our sixth slice of 30 degrees, we get 6 times pi over 6, which just gives us pi. As we move through quadrants 3 and 4, notice that as we continue to add 30 degrees or pi over 6, that the numbers build. But you're still looking at 7 pi over 6, 4 pi over 3, 3 pi over 2, and then 5 pi over 3, 11 pi over 6, and then you will be back to 360 or 2 pi. Okay, here is the unit circle radii measures, but this time we are with pi over 4, which is 45 degrees. Okay, and if we have two of those, 45, 2 times pi over 4, that's going to give us pi over 2. If we have 3 of those, then we get 3 pi over 4. If we have 4 of those, then we get our pi. Notice as we move through quadrants 3 and 4, we have 5 pi over 4, 3 pi over 2, and then 7 pi over 4. And then again, we are back to the 2 pi. So when you look at this, this is our unit circle with radian measures. And you'll notice that the pi over 6, pi over 4, pi over 3, they really repeat. It's just as you add more angle to each one, they just become larger. Okay, and here's our angles that we're looking at in the degree measures. Now we're going to convert from degrees to radians. Okay, so recall that 180 is equal to pi. So pi over 180 converts degrees to radians. So here's an example. So we have 25 degrees. We're going to multiply that by pi over 180, and that's going to equal 25 pi over 180, and then we reduce. You must always reduce. Okay? And then we have 180 degrees over pi, and this converts radians to degrees. So we have 5 pi over 18 times 180 over pi. Notice how easy the pi's cancel. And then you just go ahead and reduce. So 18 goes into 180, you get a 10 left, and then 5 times 10 is 50. Let's do a few more examples. Okay, here's one example, 36 degrees. We're going to multiply that by pi over 180, and what are we going to get? Remember to reduce. That's right, we're going to get 36 pi over 180, which is going to reduce to pi over 5. Let's look at our next example. Okay, we have 99 degrees. Again, we're going to multiply that by pi over 180. And what is going to be our final answer? Remember to reduce. Okay. So we have 99 pi over 180. We're going to reduce that, and we get 11 pi over 20. All right, let's take a look at this. Now we have 3 pi over 10. We're going to convert that from radians into degrees. So we're going to have 180 degrees over pi. Again, notice how easy this is. The pi's cancel. And now you're just going to reduce your numbers. So then our answer is going to be, we'll have 540 over 10, which will give us 54 degrees. Let's do one more example. Notice that we have 5 pi over 12. We're going to multiply that by the 180 over pi. Go ahead and solve for this. Remember to reduce. All right, that's going to reduce to 75 degrees. Okay, so there's where's our examples. Thank you for your participation. The end.